You can use a percent to describe how much something has increased or decreased. Here is the original height of the flower. A percent of change describes how much a quantity has changed, expressed as a percent of the original quantity. You can use the percent equation to find the percent of change. The percent is the percent of change. The whole is the original quantity. And the part is the amount of change that happened. To find the formula for percent of change, divide both sides by the original quantity and simplify. Percent change equals the amount of change divided by the original quantity. When a quantity increases, the percent of change is called a percent increase. Suppose the flower grows 5 centimeters, from 10 centimeters to 15 centimeters. Use the formula for the percent of change. In this case, the percent of change is a percent increase. The amount of change is 5 centimeters, and the original quantity is 10 centimeters. Simplify the fraction to 1/2. The fraction equals 5/10, or 50%. The height of the flower increased by 50%. When a quantity decreases, the percent of change is called a percent decrease. Suppose the flower shrinks 5 centimeters, from 20 centimeters to 15 centimeters. Use the formula for the percent of change. In this case, the percent of change is a percent decrease. The amount of change is 5 centimeters, and the original quantity is 20 centimeters. Simplify the fraction to 1/4. The fraction equals 25 hundredths, or 25%. The height of the flower decreased by 25%.
That's it. Keep it going, Toby. 28, 29, 30. That's good. Good work.
112, 113, 114.
114. That's very good, Carl. Keep working that core. You guys are getting stronger every day.
Identify the percent increase in each situation.
You know that a percent can describe the relationship between a whole and a part of that whole. In the case of one number changing to another number, like the number of push-ups that Toby can do, you can also use a percent to describe this change using the same percent equation. Man, percents are flexible, and I'm getting there.
In order to figure this problem out, we can use the percent increase formula, which is amount of change over the original quantity. But we can also use the regular percent equation that we've been using, which is part equals percent times whole. But in this case, part represents the amount of change, the percent represents percent increase, and the whole represents the original quantity. So let's go ahead and work out this push-ups. So what is the amount of change? And to get the amount of change between 30 and 15, all you have to do is subtract the two numbers. What is 30 minus 15? Well, that equals 15. So that will be our part, which is 15. And what is the percent increase? Well, that's what we're looking for, so we'll just use a variable. And our original quantity is from month 1, which is 15. So we'll use that. Now we have to isolate our variable by dividing 15 on both sides of the equal sign. I'm left with x on here on this side and then 1 on this side. But remember, 1 is not the final answer. That's the decimal form of the percentage. So we have to convert 1 to a percentage by multiplying by 100, or you can remember to move the decimal 2 times to the right. So it will look like this: once, twice. You add your decimal point and then you add your 2 zeros. So the increase for the push-ups is 100%. Now we can start working on crunches. So before we figure this out, we have to know how to figure out if the answer is going to be a percent increase or decrease. Now we look at the 100 from month 1 to the 114 from month 2. We know going from 100 to 114 is an increase. So this will let us know it's a percent increase. Even though it says it's right here, all questions will not let you know if it's a percent increase or decrease. You will have to figure that out. But now we can go ahead and start substituting our information in. So our equation is part equals percent times whole, which in this case, the part is the amount of change. And to figure that out, we have to subtract month 1 and month 2. And when we subtract 114 and 100, we get 14. So that lets us know what our part is. Our part is 14. Our percentage, well, we don't know that yet. That's what we're trying to figure out. So our percent is, in this case, the percent increase. Our whole, it is the original quantity. So we have to look at month 1, which is 100. Now I'm going to go ahead and isolate my variable by dividing 100 on both sides of the equal sign. And I'm left with x on the right side of the equal sign. And 14 divided by 100 is 14 hundredths. But remember, this is the decimal form of your answer. We need to change that decimal to a percent by multiplying by 100. Decimal percent multiply, or you move it to the right 2 times. So the percent form of 1400 is 14%. So to answer this one, there is a 14% increase.
On Earth, I weigh 154 pounds. On the moon, just 25.5 pounds. Fortunately, everything else weighs much less up here as well. Check it out. I could never do this on Earth.
The force of gravity on the moon is different from the force of gravity on Earth. This means that an object has a different weight on the moon than it does on Earth. By what percent does an astronaut's weight decrease on the moon?
This is a percent of change question. And in this case, this is a percent decrease problem because we're comparing the Earth to the moon. So Earth, you can see here 154, and then you go to the moon, it's 25 and 5/10. So that's decreasing. All right, the first thing we have to figure out is the amount of change. And to get the amount of change, we're going to subtract these two values. And remember, when you are subtracting decimals, you have to make sure you line up the decimal points. Make sure your ones place is lined up. You add a decimal point and a 0. Remember, with the amount of change, you are subtracting. So I lined up my decimal points. Now I have to go ahead and subtract. Make sure you regroup. 10 minus 5 is 5. 13 minus 5 is 8. 4 minus 2 is 2. And then you add your 1. So the amount of change is 128 and 5/10. Now our percent decrease, we don't know, so I'm going to use a variable and I'll use x. Our original quantity is the value or the weight on Earth, which is 154. Now I need to go ahead and isolate my variable. I see the variable in 154 is connected through multiplication. So the inverse of multiplication is division. So I need to go ahead and divide 154 on both sides of the equal sign. When I cancel that out, I'm left with x on this side, and then I have to simplify. 128 and 5/10 divided by 154, it is a long decimal. I'll just write 3 decimal places. Now you have to remember to change your decimal to a percent. Decimal percent multiply, or you move it to the right 2 times. So that'll be 83 and 4/10. Don't forget to write your percent symbol. So to answer this question, by what percent does an astronaut's weight decrease on the moon? The astronaut weight decreased about 83 and 4/10%. Now I said about because we rounded that.
Every 10 years, the U.S. government takes a census, or survey, of the population. One possible result of changes in population is that the number of U.S. representatives for a state may change. Find the approximate percent decrease in the number of representatives for Michigan. Drag the dots to estimate the percent of change.
All right, we're going to go ahead and work this out by using the percent equation. And the percent equation is part equals percent times whole. Now remember, the part is the amount of change, and to get that, we are going to subtract the original and the new value. So that's 20 minus 11. And 20 minus 11 is 9. So that will be our part. We're going to use 9 for our part. Our percentage is unknown, so I'm going to use a variable. Our whole, remember that is the original. Here it is 11. That is our original. Now I need to go ahead and isolate my variable by dividing 11 on both sides of the equal sign. 9 divided by 11 is a repeating decimal. Now we need to go ahead and convert that decimal to a percent by multiplying by 100% or moving the decimal point 2 times to the right. So that'll be 81, and let's go ahead and write 2 more numbers after the decimal point. So if the 81 is repeating, 81 will come next. And remember to write your percent sign. So let's go ahead and round that percentage. Let's round it to the nearest whole percentage, so the ones place. When I round that to the ones place, you have to look at the tens place. And if that number is 5 or more, you have to raise the score 4 less, let it rest. So this will round to 82%. So the percent increase is about 82%. Now we know it's an increase because it's going from 11 to 20, and that number increased, so that means the final answer is going to be an increase.
Drag the dots to estimate the percent of change.
All right, here is another problem just like it was before. But let's figure out if it's a percent increase or decrease. So the original is 120, and then it went to 65. And we know the number went down, so this is going to be considered a percent decrease. But we're going to use the exact same equation. Part equals percent times whole. Our part is the amount of change. So remember, you have to subtract the 2 values. And 120 minus 65 is 55. So that is our part. 55 is our part. Our percentage is unknown, so we're going to use a variable. Our whole is the original, which is 120. Now I need to go ahead and isolate my variable by dividing 120 on both sides of the equal sign. 55 divided by 120 is a repeating decimal. So that's 0.4583, and the 3 is repeating. But remember to change your decimal to a percent by multiplying by 100. Decimal percent multiply, or you move it to the right 2 times. So that'd be 45. And then the 3 is repeating. But let's go ahead and round that to the nearest whole percentage. So when I round that, that will be about 46%. About 46%.
Estimate the percent of change.